Good afternoon, class. Today we're going to expand on solving system of equations. Yesterday, or today actually in class, you did a lot of graphing that had to do with finding where two lines will intersect, and that is called the solution. Well, I'm just going to review a little process that you've done in the past so we can use this process today. This is solving just an equation by doing a substitution. If we have an equation, y equals 2x plus 2, and I tell you y equals 6, we can just substitute 6 in for y. So instead of y, we'll put 6 equals 2x plus 2, and then we could solve for x. So to solve for x, we would have to do our subtracting so that we could get x by itself. We get 4. And then we would divide by 2 to get x equals 2. So that would be the solution, if you may, to that equation for x equals 2 when y equals 6. So we're going to do something very similar today, but we're going to give you two equations, and you're going to have to solve for the equation, both equations solution. So for example, if I gave you the same equation, y equals 2x plus 2, and then I gave you another equation, y equals 3x plus 4, we're going to do a solution to that. Now yesterday you graphed those two equations. Today we're going to solve these algebraically. So let me give you the steps for that. So you're going to want a notepad so you can write these steps down and you can use them to solve system of equation by substitution. So the first is to write both equations as y equals mx plus b. So that's the first step. You have to get both equations so that they're in slope-intercept form, which we're just using stuff we learned from chapter 6. We learned how to rewrite equations so that they're y equals mx plus b. Then we're going to set both equations equal to each other. So we're going to end up with two equations, both written y equals mx plus b. So we're just going to write mx plus b equals mx plus b. So there's no y now in the problem. Now m and b will be numbers, obviously, but these are just steps. These are things that you can use on a test or a quiz, notes. And then we just solve for x. Now that just gives you one part of the solution. And we'll do an example here in a moment, so if you're a little confused as the process, write the process down and we'll do an example in just a moment. So we solve for x. After we've solved for x, we need to find what y equals. So we take that answer for x and we go back to one of the original problems and we substitute that number in for x. And then we solve for y. So those are the steps to solve a system by substituting. So we're going to get an answer for x and an answer for y. So we're going to get both answers by doing this algebraically. Just like you did yesterday, you got an x and a y, or today in class, but we're not doing it by graphing. We're doing it algebraically. So here's an example. Y equals 2x plus 2, and y equals negative 3x plus 4. We're going to take and set the two equations equal to each other. So we take the y equals 2x plus 2, and in place of y, we're just going to take the y out, and we're going to put the other equation, negative 3x plus 4, in its place. Since they both equal y, we can substitute that. So we've taken and put it in that place. Now it's just a matter of getting x by itself. So we're going to try to get x isolated and by itself. To do that, we need to add 3x to both sides. So we're going to take and add this 3x to the other side of the equation, and 2x plus 3x is 5x. So we're just taking and getting the x's on the same side. The next step would be to subtract 2 from both sides. So minus 2, and that gets you 2 equals 5x. And then the last step would be to divide by 2, or divide by 5, excuse me. Divide by 5, divide by 5. That gets you x equals 0.4, or we often rewrite it as a fraction, 2/5. So 2/5 or 0.4 for your answer. So that's x, but remember, we need two answers. We also need to know what y equals. So we go back to one of the original equations. And again, it doesn't matter which one of these two we use. We're going to use either one of the two equations. We can use this one for this problem, and then we may use the second one from another problem. So we're going to take and put 0.4, or if you want to leave it as a fraction, 2/5, in for x. This is just a substitution, and we put it in for x. So look up here at the equation. Right here for x, we're just going to put what we got for x. That was a number. We found that x. And then we just calculate it out, and we get y equals 2.8. So that means that the solution to this system is the ordered pair 0.4, 2.8. That is the solution to this system. So we're going to do a couple more examples here so that you can get a good understanding of this, and then we'll do some practicing in class. Here's another one. In order to solve this one by substitution, we need to first rewrite them so that they are y equals. Notice both of these equations are in standard form. So we're going to rewrite these. We're going to take the equation negative 2x plus y equals negative 1, and we're going to rewrite that so that that is y equals. So to do that, we need to get this negative 2x to the other side, so we're going to add it. Now we can't take and add 2x to negative 1. We've talked about this in class in chapter 6, but we can write that as 2x minus 1. So that one now is in slope-intercept form. Now let's take the other equation, which is going to have an added step, and rewrite that in slope-intercept form. Subtract 4x from both sides. We cannot take 4x from 12, but we can certainly write it. We're left with 2y on this side. Those x's now are gone, and we moved it to the other side. And we get negative 4x plus 12. Now you'll notice I always like to write the x term first. It's just a personal preference. You can certainly write that as 12 minus 4x, but personal preference for me, I like to have the x term written first. So the last step would be to divide by 2. As we learned in chapter 6, we have to divide everything by 2. So it's a little different than adding and subtracting. When you divide, you have to divide everything. So we get y equals negative 2x plus 6. We now have both equations written y equals. We took both equations, negative 2x plus 1 plus y equals negative 1. We rewrote that. And then we took 4x plus 2y equals 12. Now, this is a long process. We're not done. We're just scraping the surface of starting this problem. So we're now going to take these two equations and set them equal to each other. So we're going to take 2x minus 1 and set that equal to negative 2x plus 6. Again, we're just going to get rid of the y for now. They're both equal to y. We're just going to set them equal to each other. And then we're going to come back and find y after we find x. So we have an equation where there's two x's, so we need to get this negative 2x moved to the other side. So if there's adding and subtracting going on in the problem, you have to add or subtract to move things over. Once you've gotten rid of the adding and subtracting, we can start to divide. But right now there's still adding and subtracting, so we're going to get rid of this negative 2x by adding it to the other side. So we get 4x minus 1 equals 6. We still have subtracting going on, so we're going to add 1 to both sides. And we get 4x equals 7. And then we divide by 4. And we get an answer of x equals 7/4. Now I don't have a calculator handy, so I'm just going to leave it right in fraction notation, which is perfectly fine. 7/4 is a perfectly acceptable answer. So now that we have x equals 7/4, I can take and substitute that in for x in either one of my equations. So I can choose this equation here and put -4, or excuse me, 7/4 in for x, or I can choose this one here and I can put 7/4 in for x. I'm going to use the y equals 2x minus 1, and I'm going to put my 7/4 right in there. So y equals 2, and then instead of writing x, I'm going to write 7/4 in parentheses, and then I'm going to subtract 1. So I have to multiply first, so I'm just going to put that over 1 so I can multiply it. 2 times 7, 14, over 4 times 1. And 14/4 will reduce, or simplify if you may. That will simplify down to just 7/2, because 2 goes into both of those. That's 7/2 minus 1. And I'm going to get, let's see, 7/2 is really 3 1/2. Minus 1 will be 2 1/2. So my solution would be x being 7/4 and y being 2 1/2. So those are perfectly acceptable answers. You can change them both to mixed numbers or both to improper fractions, and you would have an acceptable answer. So that's how we're going to be solving a system by substitution. And I'm going to have you write one down and have you bring it to class for us to look over. So let me get to that example. Let me find that example. I have one up here, and find that one here. Here we go. I would like for you to do, and I'll highlight it for you so you can actually see which one it is I want you to do. I want you to do this one right here. Y equals 4x minus 3 and y equals 2x plus 13. So you're going to solve that system right there. I want you to come to class with a solution to that system. Now I'm giving you one in y equals mx plus b, so you don't have to move things around. But do understand in class you'll have to move some things around. So if you would, come to class with those two problems solved for x and y, and we will go over this in class.